So one of my students the other day proposed a method to take a derivative that was much easier than the normal means. The problem we were talking about was this slightly funny piecewise function. So this is not too crazy. It's essentially two parabolas with an oscillating sine wave squeezing in between. And as it approaches zero, it oscillates infinitely. And as it turns out, the question was asking the students to show f prime of 0 is equal to 0. And I'm not going to do it, but the way it ought to be done is to take the limit as h goes to 0 of f of h minus f of 0 over h, just invoking the definition of derivative at 0. But the student proposed something very simple, and it gave them a right answer. They essentially said that f of 0 is equal to 0, which is not incorrect. That's literally what the function is defined as. But it was at this point I was getting a little bit nervous. After this, they said that, well, f of 0 is equal to 0, so just take the derivative. And f prime of 0 is, the derivative of 0 is 0, right? So their answer was f prime of 0 is equal to 0, which is the right answer, but basically only by coincidence. The method itself has a big problem with it, but rather than explain it right away, I want to do a quick other second example to give you the gist. Let's take a function g of x is equal to x cubed, and let's say we want to find g prime of x at x is equal to 1. Well, to take a quick picture, this essentially looks like a cubic. So at x is equal to 1, we'd expect to get some, that was terrible, we'd expect to get some upward slope, right? Some non-zero slope. But if we try to use the proposed method, right, this becomes g of 1 is equal to 1. So g prime of 1 is equal to, well, I guess the derivative of 1 by this method is going to be 0. So we get into this very funny pattern where if you try to plug in the x value first and then take the derivative, well, I'm hoping you're seeing the pattern, but it pretty much will always end you up at 0. And that's obviously not generally true. So something must have gone wrong. And the lesson for the take-home lesson from this is that you should never plug in a value of x before taking the derivative. The way you ought to do it for this particular problem is to first take g prime of x is equal to 3x squared. So that way, g prime of 1 is equal to 3. That's a perfectly reasonable positive slope, which, based on our rough image over here, seems to be probably correct. The big takeaway lesson here is that you should never be plugging in a value and then taking the derivative of a straight up number. You should instead be taking the derivative of a function and plugging it in to evaluate the slope at a point, or you can rely on the original definition of the derivative. Either of those ways are perfectly fine, but please do not plug it in and then take the derivative. That's the quick take-home lesson. But if you kind of want to understand why this is broken, we should talk quickly about the differences between numbers, functions, and operators. Now, the idea behind a function is something that takes a number like 1 to a different number, such as 2, right? It takes it from a domain to a range. Let's call that function f. Well, an operator is sort of a function's function. It takes a function f to some other function g. And the premier example of an operator that you'll see at calculus is the derivative. Think about what the derivative is doing. It takes some function f of x and takes it to f prime of x, which itself is a function. If you take some function, make it simple, f of x is equal to 2x, and you take the derivative, that gives you f prime of x is equal to 2. This 2 over here is a perfectly valid function itself. It's a constant function that no matter what value of x you spit it, it always turns back 2. And a constant function is not to be confused with a number, because a constant function you can totally take the derivative of, which is just going to be 0. Right? And the 0 itself is also a constant function. Equal. But we run into this issue here where if we try to evaluate it first and plug in x is equal to 1, we run into this issue of f of 1 is equal to 2. Now this 2 is not a function, it's a straight up number. And it's totally nonsensical to try to apply an operator, which, again, an operator is supposed to be something that acts on a function to spit out another function. Operators do not act on numbers. So this process would be nonsense. This notation here, where f1 is equal to 2, looks a heck of a lot like this notation, f prime of x is equal to the constant function 2. We don't really make a distinction between when 2 is a constant function and when 2 is just a number. And that, I would hazard, is probably why the mix-up happens for many, many students, including myself when I was taking calculus. Yeah, that's it. I hope that helps. Make sure to remember not to plug it in and then take the derivative on a test.